For example 2, we have Belena recorded the possible sums that can occur when you roll two four-sided dice in an outcome table. We display the following sets in one Venn diagram, so the rows that produce a sum less than 5 and rows that produce a sum greater than 5. So first of all, for this question, we need to make our sum table. And so I'm going to make a chart that is 4 by 4. So 1, 2, 3, 4 across the top, and down the side is 1, 2, 3, 4. Make my lines. And then start adding. So in my top left corner, 1 plus 1 is 2, and then next to that, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, and then we drop down, so 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5, 6, so on and so forth. Just a reminder, sum means add. Just going to fill in the table here, so 5, 6, 7, and 8 for 4 plus 4. Okay, from there, I'm going to create my sets. And so we need rows that produce a sum less than 5. So I'm going to just switch my pen, and then I'm going to circle the ones that are less than 5. So this guy, this guy, this guy, this guy, this guy, and this guy. So there's 6 of them. And then switch my pen again and do my greater than 5. So this one, this one, this one, this one, this one, and this one. So we also have 6. Okay, so now I gotta start defining my sets. So we're gonna have, I'm gonna use S for sum for our first universal set. So that is all combinations will be my universal set. Then we'll use, I don't know, an L for the less than 5. So I'm going to list off the ones that are less than 5. So I'm going to, because we're wanting to know what combinations produce less than 5. So I'm going to put the combinations. So like the top left corner was 1 and 1, which made 2. Next one beside that is 1 and 2. So I am reading off the row first, then the column. So the one beside that one is 1 and 3. Drop down. So we got 2 and 1, which is different than 1 and 2 because they're rolled in different orders. Next one is 2 and 2. And then the last one is 3 and 1. So I should have 6. 1, 2, 3, 4, 5, 6. So that one's good. And then I'm going to do we'll do G for greater than. And I'm going to list off all the green ones. So we had 2 and 4 for the first one. And then dropping down a row, we got 3 and 3. And then we have 3 and 4. And then 4 and 2. And 4 and 3. And then 4 and 4. Also 6, 1, 2, 3, 4, 5, 6. So, okay. So now I've defined all 3 of my sets that I'm going to be using. And so the last part of the question is to make a Venn diagram out of it. So I'm going to start with a box to represent my universal set, which was S. And then I'm going to use L and G for my Venn diagram. And looking at L and G, there is no connection between the two. There is nothing that is the same. So I'm going to have 2 circles that are not connected. One is going to be L and the other one's going to be G. Just a note, when I'm doing my Venn diagrams like this, I can just put the lettering down because I've already defined what those letters are. If I don't do this first, then I have to put the combinations into the bubble. So the final part of this question is record the number of elements in each set. And so when we're doing number of, the set notation we use is we put an n first for the number of, and then in brackets we put what set we're talking about. So I'm going to use S for the universal set. So I want to know the number of elements in the universal set. So if I look back at my chart, I have 16 different combinations. So that means I have 16 elements from my universal set. Then I'll do N for, and then for L for my less then set, and there's 6 different things, 6 different combinations, so 6 different elements. So the number in L is 6. And then we put NG, so the number in G, which is also 6. So just note when you see the N out front, you're wanting to know how many elements are inside the set, not what those elements actually are. So just a quick guide, so keep this page handy. Sets can be represented in 3 different ways, and so we used words sometime to represent them. We listed each individual element when they were small enough, but when they started getting large, we used set notation. So we defined what variable we're talking about and then told what our variable is and what number system that variable fell into. So, and then the sum of the number of elements in a set and its complement is equal to the number of elements in the universal set. So if I take my set, add to that everything that's not in that set, I will get to my universal set. And then when 2 sets A and B are disjointed, so when A and B have nothing to do with each other, if you add them together, you will get to your universal set. So in summary, sets are equal if they contain exactly the same elements, even if the elements are listed in different orders. You may not be able to count all the elements in a very large or infinite set. You can show how sets and their subsets are related using Venn diagrams. You can often separate a universal set into subsets in more than one correct way.